Have you ever encountered a computer program that seems to be running, actively consuming resources, but just cannot get anything done? Or perhaps one that simply freezes up completely, becoming unresponsive no matter how long you wait? These frustrating scenarios often point to one of two distinct but related concurrency issues in software: livelock or deadlock. The fundamental difference lies in the state of the participating processes. A deadlock occurs when two or more processes are permanently blocked, each waiting for a resource held by another process in the same cycle, resulting in complete stagnation. In contrast, a livelock happens when processes continuously change their state in response to other processes without making any meaningful progress, akin to an infinite loop of active but fruitless effort. To understand this more deeply, consider the conditions for a deadlock. It requires mutual exclusion, meaning only one process can use a resource at a time. There must also be a hold and wait condition, where processes holding some resources request new ones. No preemption means resources cannot be forcibly taken from a process. Finally, a circular wait means a chain of processes exists, where each process in the chain waits for a resource held by the next process. When all four of these conditions are met, a system falls into a deadlock, and processes halt indefinitely. Livelock, on the other hand, often arises as an unintended consequence of poorly implemented deadlock prevention or recovery mechanisms. Imagine a system designed to resolve deadlocks by having processes releases their resources and retry if they cannot acquire all necessary ones. If two processes continuously releases and re-request resources simultaneously, reacting to each other's actions in an endless cycle without ever successfully acquiring all needed resources, they enter a livelock. They are actively executing code, releasing and acquiring, but no true work is completed, making it a state of constant activity with no forward motion. Detecting a deadlock usually involves observing that involved processes are completely idle and waiting, often visible through process monitoring tools showing zero CPU usage for the affected threads. A livelock, however, can be more insidious. Processes appear busy, consuming CPU cycles, but the system's overall output or state remains unchanged. This busy waiting behavior can often be diagnosed by carefully observing system logs or debugging specific execution paths to see if processes are merely repeating the same set of actions endlessly. Recognizing the subtle distinction between processes that are waiting versus processes that are busy doing nothing is crucial for effective debugging. A deadlock means a complete halt, requiring intervention to break the cycle. A livelock means active but unproductive work, requiring a reevaluation of the coordination logic to ensure actual progress can be made. Understanding these nuances helps developers design more robust and efficient concurrent systems, ensuring that processes can indeed reach their desired outcomes.
If this helps you fix faster, like, subscribe, and keep debugging with us.